Welcome back. Let's resume. We are done with 1.1. A radar unit is used to measure the speed of automobiles on the expressway during the rush hour traffic. The observer measures the speed of randomly selected 76 cars and obtains the mean speed of 62 miles per hour. 1.1 was kind of like this. We are looking for 95% confidence interval. So here is the initial picture. The middle has to be 95%. Well, this is review, so let's use a little bit different figure. For example, if I change this into, say, 98%, then this middle number should be changed to 98%. This one here is half of the remaining 2%, so 1% to the right, 1% to the left. Just give me a moment. So we want to change this confidence level to 98%. Okay, here we go. 98% in the middle, so 1% there, 1% there. And we are looking for, at this time, 98% confidence interval. All right, we've done 95% confidence interval in previous videos, so let's do this very, very quickly. Let's find out x1. How do you find out x1? End minus center over SE is approximately equal to appropriate z-score. That's what you have to do. And what is the standard error here? Standard deviation is 4.95, so the standard error should be 4.95 over square root of n. Now what is the z-score associated to 1% here? Remember, this is 98% confidence interval this time, not 95%. So what do you have over here? Let's look at the z-table for 1%. And let's see which number is closest to 1%. Here we go. 0.0099. I think that's closest to 1%, isn't it? The other one is 0.0102. This is closer. So let me take negative 2.33. So this is negative 2.33. And solving this, you're going to get this left-hand side endpoint. So x minus 62 is approximately equal to negative 2.33 times 4.95 over square root of 76. If I flip this denominator to the other side by multiplying, and consequently x is approximately equal to 62 plus, no, we have to minus all that. That's it, isn't it? We just flip this subtraction by 62 to the other side. So we have positive 62. And all we have to do now is to calculate this quantity over here. And it's about 60.67. I'll estimate it as 60.7 as my left-hand side endpoint. Now what if I find out the right-hand side endpoint? It's gonna be (62) plus this quantity because of the symmetry. Remember, we went left previously, so this time we have to move to the right. And this computation yields about 63.3. So I'll estimate it as about 63.3. So the confidence interval the 98% confidence interval is about 60.7 to about 63.3. We'll make this kind of conclusion. Okay, that was a quick review, really quick review for a modified problem. Instead of 95% confidence interval, I've reviewed 1.1 using 98% confidence interval. Okay, I reviewed it quickly, so let's move on to 1.2. Let's find 95% upper confidence bound using the standard deviation of this previous problem, 4.95. So this is upper confidence bound. So instead of the interval, we'll have just one endpoint here. Upper confidence bound, so it is the upper limit above the observed mean of 62, and just this one, and the probability of real mean falling less than that all the way over here is 95%. So we have this 95%, the blue part, and then of course there's 5% of chance that my estimation is wrong. So how do you find this x? Well, we use the same thing. N minus center over SC is your z-score, and z-score has to be the left-hand side shading of 95%. Here we go. Okay, I just copied and pasted this picture. N minus center, x minus 62 over SE, and SE is standard deviation over square root of n, and this is formula number 1, and that's associated to the z-score of the 95th percentile, the 95% in this blue part, and that's gonna be about 1.645. Shall we check? Here we go. This is the z-table here, and this shaded probability has been 95%, so it should be the second page. Here, this one. And let's find out z-score closest to 95%. Where is it? Well, here we go. These two numbers will do 0.9495, 0.9505. So 1.64 and 1.65. And real 95% must be somewhere in the middle, and they're kind of pushed. So let me estimate it as 1.645. Not 1.64, not 1.65, but in the middle, 1.645. That's how I got this right hand side. Solving this equation is not too bad. Just flip this denominator to the other side, and that yields this, and then flip this subtraction by 62 to the other side, we get that. Punch your calculator in, you're gonna get 62.93, approximately speaking, 62.9. That's gonna be your 95% upper confidence bound. Now what if somebody changes a problem into not 95% confidence bound, but let's see, 97% upper confidence bound? Then what would you do? This probability here should be not 95%, but 97%. Should be a little bit bigger. So this blue point, purple point should move a little bit to the right, and this red region will become a little bit smaller. Let me correct this program just a little bit, excuse me. So that's 97% here. Okay, here we go. We have 97% here and 3% there, and you're looking for this x value. The solution method should be the same. N minus center over SC over here should be your z-score, but this z-score will be a little bit different. 1.645 was for 95%. I just changed this problem into 97%, didn't I? So let's go over to the z-score table here and let's look up 97%. 97%. I think this is the closest. 0.9699, and that's 1.88, isn't it? 1.88. Do you see? 1.88. So instead of 1.645 here, I'm putting 1.88. And you can solve the same problem in the same process. Flip the denominator and flip the mean, and then just run your calculator. You're gonna get 63.07 approximately speaking. That was 97% upper confidence bound. Can you do the same thing or same kind of adjustment if I change this into something still different? 92% or 88%? No matter what I put in, you should be able to do the same thing.